Hello, everybody. This is Mr. Giancarlo's cousin from England. You've tuned into What's Up with Giancarlo. Ha, gotcha. You're watching What's Up with Giancarlo. Me and only me. The one and only. Today, we're rocking with topic 6, lesson 2. Use proportions to make predictions from data. All right? The standard I can use proportional relationships to make predictions about a population. Standard is MA.7.DP.1.3. Given categorical data from a random sample, use proportional relationships to make predictions about a population. All right, let's get started. Had a little fun, got that out of the way. Now we're getting into math. Ooh, 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 ooh. All right, example 1. Understand populations and samples. The 2,468 registered voters in Adalia's town are voting on whether to build a new stadium. Adalia and her friends want the town to vote in favor of the new stadium. How can they determine how the voters will vote before the day of the vote? That is a very good question. And as we can see, Adalia and her friends could ask every registered voter or the entire population of voters in town how they plan to vote. That would take a long time. They can ask all 2,468, and that would be very accurate as to how they're going to vote. But that would take them a very long time. Or Adalia and her friends could ask a subset or a sample, as we like to call it, of the registered voters in town how they plan to vote. So a sample would be like picking out 100 to 200 people, which is a lot smaller of a number than the entire population. So it would be easier to pick those people out, like 100 to 200 people, and figure out how they're going to vote, and then use that to represent the entire population. So as I made this little drawing, big circle is the population, and the little circle inside the population would be a sample. So that's like asking my class and saying I only care about my class. My class is the population. Which Skittles they like, the original red wrapper or the the tropical blue wrapper. Okay, so my whole class would be a population, but if I was too lazy to ask everybody, I would ask maybe 5 or 6 kids, and that would be a sample of the population, which is my class. Okay, or if the whole entire school is the population and I want to ask everybody that question, I could just get a sample size, which is just my class that I have. So that's the difference between sample and population. Population is the entire in everybody in entirety that could vote, and then the sample size is just a little group of the population. Okay, let's move on. Example 2, describe a representative sample. So Morgan decides to survey a sample of the town's voting population. How can she know that the survey results from the sample of voters represent the position of the entire town's population? So a representative sample accurately reflects the characteristics of the entire population. In a random sample, each member of the population has an equal chance of being included. A random sample tends to be a representative sample. So a representative sample is saying that like this sample will be good to describe the actual representation of the population. So if I get a representative sample of Skittles, and it would be like it would turn out that most kids like the original compared to tropical, and then we get the entire population and it votes and the vote works out that it's more to original over tropical. So a representative sample is like a more responsible sample of people. Like a random sample is completely not knowing who I'm picking. Everybody has an equal chance. I just take a hat, I put in a whole bunch of little pieces of paper with ones on it, and then I put 5 pieces of paper with twos on it, and then everybody has an equal chance of picking a two, that could be part of my sample. Okay, so that is the difference between a random sample and just a regular sample. And then random samples tend to be a representative sample, and random samples tend to work out. Okay, on behalf of the entire population. So please remember population sample, representative sample, and random sample. Those are all important vocabulary words. Okay. So moving on to example 3, we're actually getting into math. We're not just dealing with vocab words now. Um, example 3, use proportional reasoning to make a prediction. This goes back to proportions. We did this in topic 3. Hopefully you guys remember that. I don't know if I have any videos. Maybe I do have some videos. You guys can go back and check them out. So a town, this is an A. Sorry, this is an A. A town will soon be voting on building a recycling center out of a random sample of 200. Oh, a town will soon be voting on building a recycling center. Out of a random sample of 250 voters, it was found that 165 voters are in favor of building the recycling center. So there's no exclamation question mark. There is just a period. So part A, out of, this is an O, out of a total of 55,000 voters, how many do you predict will vote in favor of the recycling center? So we make our proportion. We have one fraction equals another fraction. Okay? So what's happening is the number surveyed in favor over the total number surveyed. So we want to know about the people voting in favor, and that's what they give me here. So we put the part or the people in favor, 165 on top, and that goes over the total number surveyed. The total number in my sample will go on the bottom, so I get 250. Okay, and then on the other fraction of my proportion, it is the total number in favor of the actual population that are voting, which would be V. We don't know. We do not know that. And that goes over the total number being the total number of voters, which is 55,000. All right. So now, like we did in topic 3, trying to find percentages and parts and wholes and everything, we multiply across, not side by side, across, we multiply across 55,000 times 165, and then we divide it by the last number, which is 250. So I will rewrite this. We get 55,000 multiplied by 165, and then we divide it by 250. So I'm taking it step by step. So in my little handy dandy calculator, 55,000 times 165 gets me 9,075,000. And then that goes over 250. Okay? And then I will divide that 9 million by 250 on my calculator, and I will turn out with 36,300, just like they do over here. So I know I'm correct. Okay? So that is my prediction for how many people will vote in favor of the recycling center. But now I'm going to check part B. The table gives the actual results of the vote. Why is the predicted number of voters in favor different than the actual number? So class, when I take a sample size, when there are sample sizes involved, there's no way we're going to get the actual vote. This is just an estimate. It is our guess. You can call it a guesstimate if you would like. So this is our guesstimate using a sample. A random sample is a good point of view for the actual vote, but it will not give us the actual vote because we need every single person in the population to give us the legitimate results. This is just a guesstimate to see what we think is going to happen, and what we got was we think it's going to be passed for the recycling center. But these are the actual results. So a random sample is just a subset of the entire voter population. So the actual results may be higher or lower than predicted. Okay? Which makes sense. Okay? We're just using math to figure it out. Let's go to example 4. Example 4, use proportional reasoning to estimate. This is the same exact thing we just did before, okay? Derek is writing a report on cell phone usage. He collects data from a random sample of 7th graders in his school and finds that 16 out of 20 7th graders have cell phones. If there are 290 7th graders in his school, estimate the number of 7th graders who have cell phones. So, like we did before, our sample goes first, and then we use the people that have cell phones over the total amount of people in 7th grade. So our sample is 16 because that's the part, and then the total amount of people in our random sample is 20. Okay, and then on top goes the amount of people that actually have cell phones, which is C, because we don't know how many kids have cell phones. So the total 290 goes on the bottom. And just like we did in the last example, we go 290 times 16 divided by the last number, which is 20. So we rewrite that out. We write it out. 290 times 16 divided by 20. 290 times 16 equals 4,640. We will divide that by 20. Okay? And when we divide it by 20, we get 232. So it shows us right here in the book, they get 232. That is correct. Now, class, I want you to think to yourselves, is this the exact number of people that, of 7th graders that have cell phones? No, it is not. This is just a guesstimate. Remember, we took a sample, and this can either be higher or lower than the actual amount. But this is just a guesstimate. This is like we're just thinking this is how many people we will get. And then when we actually put out a vote or a survey to all 290 students, then we will get the actual results. Okay? This is just a guesstimate. That is all. Let's move on to example 5. Use proportional reasoning to compare data. Now we have to do proportions for company A and company B. So the table shows the numbers of monthly cell phone batteries manufactured at 2 companies last month. Defective batteries did not charge properly. Out of 15,000 new batteries manufactured by each company next month, which company will expect to produce fewer defects? Okay, so the defective batteries would go on top. This is my my sample size or actual population size and everything. We're making predictions using the population. So 75 out of the 11,500 batteries were defective. That is an actual number, okay? This is not a sample size, this is actuality, okay? So it goes over 15,000. The next month is going to be 15,000. And then we're just going to use C again. Okay? That is company A. Company B will do up here. So company B had 90 defective batteries out of 12,225 batteries. Okay? So that equals the same variable over the same amount next month. They're both putting out 15,000 batteries, and it's going to be equal. Okay? So let's do A first. We do 15,000 times 75 divided by 11,500. 15,000 times 75 divided by 11,500. So that equals 75. 15,000 times 75 is 1,125,000. And then we will divide that by 11,500. And we will get approximately, it's not exact, approximately 98 defective batteries. And it tells me right here, so all the math is correct. We worked it out correctly. So for company B, we do 50,000 times 90 divided by 12,225. So let's write that. Let's write it out. This is what everybody should be doing always when we are using math. Always write out the problem and your work. So 15,000 times 90 equals 1,350,000. And we will divide that by 12,225. And we get approximately 110. Approximately. That's what these squiggly lines mean. Equal signs are straight lines. Approximately are squiggly lines. So 110, and that's what we get over here. So should we go with company A or company B? You're right, company A. We should go with company A because they have less defective batteries. Okay, and these are just predictions. Until we check all 15,000 batteries, we are not going to know for sure whether which company has less defective batteries. But this is a good guess of who would have less defective batteries. Okay, so let's go to example one. Try it. Miguel thinks the science teachers in his school give more homework than the math teachers. He is researching the number of hours middle school students in his school spend doing math and science homework each night. So the blank includes all of the students in Miguel's school. So all of the students in Miguel's school would be the population. Good. A possible blank is some students from each of the grades in the middle school. So, what would be a good answer here? You're right, sample would be a good idea. So, a possible sample is some students from each of the grades in the middle school. All right? Good job, class. Example two, try it. A produce manager is deciding whether there is customer demand for expanding the organic food section of her store. How could she obtain the information she needs? Well, what did we go over in example two? What is the title of example two? So you're right. She could get a representative sample. Representative sample. And get a survey taken to see if she needs to get a more organic food section, get a if she needs to expand on her organic food section. Okay, she would get a representative sample of her shoppers. Okay, a representative sample of her shoppers. Perfect. All right. So how many voters are predicted to vote against the building? Well, we would do 55,000 divided by minus the 36,000. That would be 36,300. So when we do that, 55,000 minus 36,300, what do we get? You're right, we get 18,700. So we would do, make that a 4, make that a 10, and then we would make that a 4, make that a 14. So that is where we get this number. And how does this compare to the final voter results? This number, the actual results are higher than this number. So that is where it is also a prediction. So let's go to example 4, try it. For his report, Derek also collects data from a random sample of 8th graders in his school, and finds that 18 out of 20 8th graders have cell phones. If there are 310 8th graders in his school, estimate. So we get 18 out of 20, right? That is our sample. So we put 18 over 20, and then we equal C over 310 because 310 is the total amount. All right, work it out. So what we do is 310 times 18, and then we divide it by the last number, 20. So we get 310 times 18 divided by 20. 310 times 18 would be 5,580 divided by 20. And we would get 279 out of 310 people. So that is based on the sample, about 279 eighth graders have cell phones in their school. Okay? It's just a guesstimate. All right? So now company C had 60 defective batteries out of 10,800. So let's do company C now. Company C has 60 defective out of the 10,800 that they made last month. And next month, they will have C defective batteries over 15,000. All right, go ahead, work it out. Okay, so you guys should have done 15,000 times 60 divided by 10,800. So let's write it out again. 15,000 times 60 divided by 10,800. And we would get, for 15,000 times 60, we get 900,000. Divided by 10,800. And when we divide those, we would get approximately 83 defective batteries. Okay? So how does this compare to the others? Well, way better. Because in company A, they had approximately 98 batteries out of the 15,000. And company B had 110. So we would choose company C. Company C is the winner. Okay? So that is the lesson. Look at these key concepts if you need a little bit of help remembering everything. And that's it. Tune in next time. You've been watching What's Up with Giancarlo. And if you've been watching, that means you're part of the class. Later, everybody.